In this video, I'll demonstrate the current evolution of the terrain editing functionality I've developed for digital implementations of hex and counter style board wargames. Of course, the functionality can be used for hex and counter wargames designed from the ground up for the computer, but most of my development work has occurred in the context of tabletop board wargame digitization, so we'll focus on that in this video. As I mentioned in a previous video I did regarding my implementation of the Phantom Fury wargame, I write applications in the C++ language using the Qt framework. It's Qt spelled Qt, like that. You might recognize this as the Qt Creator integrated development environment that comes with Qt. The terrain editing functionality I'm about to show has evolved rather haphazardly. In the past, when digitizing a wargame, I included code in the main working application to handle things like encoding terrain data for the game. I'll show you an example here. So this is a screenshot from the Phantom Fury application when it was in terrain editing mode. And you know, these red dots were coordinates that I could place through the terrain editing functionality, and these magenta boxes represented locations. You could use these points to define zones, to define blocks. You could use them to define street sections and so on. These various features, the dots and the magenta boxes and these aqua street sections, they're not just changes to the map image, they represent discrete objects that are created at runtime. But all of this terrain editing code was embedded in the same application that would be launched to play the game, which isn't really ideal. What I would do, once the application reached the point that I created the requisite terrain data using these various embedded tools, and once I started working on the gameplay code, I would comment out or otherwise suppress the editing functionality. And you know, that works fine for these kinds of informal projects, but I found that I was just making problems for myself and in reinventing the wheel too much. The terrain editing code was a bit too intertwined with the user interface and gameplay code. So, you know, when I would start a new game project reusing code from a prior project, I'd have to tease out all of the editing parts from the prior project, you know, and so rework them into the new application and, you know, find where they were. And it really wasn't the best way to do things. So I started on a new project, which is a digital implementation of GMT's game Downtown, which is about the U.S. air raids on North Vietnam from 1965 through 1972. And for this project, I tried to do things in a more orderly and reusable manner. So let's just open the Downtown project. The first thing I want to point out is I've organized my code into, there's a container project, but it's now, the code's now organized into 3 distinct sub-projects. And as you can see, there's the client version of the application. I should point out that Downtown is a 2-player game, and I'd like to allow players to play it online. So there's a client version of the game. There's a server version, which basically serves as the host for 2 client instances, or possibly more than 2 client instances if I really wanted it to open up to multiplayer play. And of course, there's the editor application. And it's the editor application that I'm going to talk about today. To look at the file structure for a second, you can see the 3, you know, the 3 folders corresponding to the client, editor, and server applications, but there's also this common folder which contains a lot of, you know, all of the files that are common to at least 2 of the 3 sub-projects. Each of these sub-projects will be compiled into its own separate executable file, which actually brings up a sore point from one of my first big game projects, which was a digital implementation of Brian Train's game Third Lebanon War, where it was also an online multiplayer game, but the I didn't have separate client and server classes and codes. So, for example, the game class, had many functions that were bifurcated into code that only would run on the server, on the player, the host player, and code that would only run on the client player, and it was such a mess. I think I still have PTSD from that. As I discussed on my Board Game Geek blog, Digital Abyss, I haven't done much coding yet of Downtown. I tried to do things the right way this time, so I made a point of trying to do a lot of the design work on paper, so to speak, before I start in on any coding. But I've done 2 read-throughs of the rule book and the scenario book, and done a fair amount of analysis and design work. So I gave myself permission to work on coding the terrain creation functionality. After all, in order to write gameplay code, there has to be a map and terrain data and things like that, so it's not the most illogical place to start. Okay, so let's start the application. Obviously, this is the downtown map. You can zoom in and zoom out using the mouse wheel. You can just left click and drag to move the view around. I think you can also, use the arrow keys to move the view around as well. And to bring up the editor tool, you just left click anywhere, and here it is. You can drag it off to a second monitor if you want, but obviously we'll leave it on screen for the purposes of this demonstration. You'll notice that the hex grid related part is grayed out. It's disabled just temporarily. That's because, just for development purposes, the hex grid has been generated in the source code itself, and so all of these parameters are specified in the source code. But if once this tool is in quote-unquote release mode, you could specify these values. And you can see that the hex grid has already been generated, because if you use this feature, you can also use H to cause the hex grid objects to show themselves. There are 3 hexagon related classes. There's hexagon itself, hexside, and hex grid. So let's take a quick look at, we can close this for a minute. So here's the header file for the hexagon class. And each hexagon has a position in a 2D coordinate system, and that coordinate system has its origin at the upper left of the hex grid. Typically, the origin of the hex grid would coincide with the upper left of the map image, and ordinarily 1 unit of distance in the hexagon or hex grid coordinate system corresponds to 1 pixel of distance in the associated map image. Just to show the application for a second, I'll show you a good example. This is from the old SPI game Operation Grenade. And let's close this for a sec, move it off screen. You can see that if you were to use this entire game board as your map image, the origin of the hex grid coordinate system would be roughly here, which is obviously way offset from the left side of the map image and significantly offset from the top of the map image, or top of the board image, I should say. So using these values, you can align the origin of the hex grid coordinate system with wherever it makes sense for your particular game. A second hexagon-related class is the hexside class. So in this application, hexsides are actually represented separately from the hexagon class. So each hexagon class will be associated with 6 hexside objects, and each hexside object will normally be associated with 2 hexagons, but in the case of You know, like for example, this hexide right here, it's only associated with a single hexagon because this hexagon would not exist. And like hexagon classes, the hexide class also has a position in the 2D coordinate system of the hex grid. And of course, the last hexagon related class is the hex grid class itself. A hex grid is actually a subclass of the array 2D class, which is a custom class that I created, but ultimately it's built around a C++ vector. So the hexagons are contained effectively in a one-dimensional array or vector, but the hex grid class internally has the semantics of a two-dimensional matrix of rows and columns, and it also presents an interface with those same semantics. So let's go back to the application, just bring up the editor again. I should point out that this value here, v1, this is something of my own nomenclature. In my hexagon and hex grid code, I've just divided up hex grids into 4 categories. So, you know, hex grids can either have the grain of the hexes running vertically like these or running horizontally like these. And in addition, you know, a V1 hex grid, if this is the very first hexagon object stored in the hex grid class, in a V1 type hex grid, the next hexagon in that row would be up and to the right. In a V2 type hex grid, the next hexagon in the row would be down and to the right. And likewise, for type H1 hex grid, this would be the first hexagon stored in the hex grid class. For type H1, the first hexagon in the second row of the hex grid is down and to the left, and then in H2, the first hexagon in the second row of the hex grid is down and to the right. As it turns out, downtown is basically a V1 type hex grid, so that is why I've hard-coded for the time being a V1 in there. I should also point out that the 3 classes I just showed you, those are all in the simulation layer or module of the source code. But the objects drawn on the screen, these hexagon and hexide objects, and actually in reality right now it's just the hexagon that's showing. But these are separately represented objects in the UI layer. So hex item is the UI class corresponding to the hexagon class in the sim layer, and hexide item corresponds to the hexide object. For what it's worth, hex item and hexide item both derive from classes in the Qt graphics view framework. And one of the reasons you want to separate UI and rules engine or simulation layers is to minimize coupling. So for example, if I ever wanted to move my application from the Qt framework to like Unity or something like that, if you have your UI code very tightly intertwined with your rules engine code, it would be a real pain in the ass to have to tease that all apart when you're installing a new user interface framework. So if you keep those 2 layers separate, it's relatively easy to swap your game rules engine over to a new UI framework. So anyway, to just show how the terrain editing works. First of all, you can switch between hexide and hex terrain editing. So if you want to apply values to a given hex, you just choose what you want. Like, let's do Haiphong. Would set it for urban. For what it's worth, it's actually a coastal hex under the rules. And if you want, you don't have to do this, but. And then all you do is position the cursor wherever you want, press the Shift key. Well, I should point out, if you look down here, if you look down at the status bar down here, you can see right now nothing is coded, so it's all just coming up as normal terrain without a name. But if we now just press down the Shift key and click the hex you want, now that, first of all, a very crude graphic comes up. These are functional at best. These are just my own crayon level drawings. It just indicate what the terrain that it is. You can also see back down in the status bar in the lower left, if you move the cursor onto that hex now, it shows that it's, first of all, that it's named Haiphong and that it's urban and coastal. And coastal in downtown coastal means for within 10 hexes of an all-sea hex side. Let's turn the the hexagon imagery off for a sec. So if you just hold down the shift key and click hexes, it'll keep applying whatever values are specified in the tool. Let's say for this is not part of, this little urban spot is not part of Haiphong, so we can clear that value and just apply the vanilla urban and coastal terrain markers to it. Show you some of the other gorgeous graphics I've implemented. For C hexes, functional at best. Let's try some rough terrain. Maybe show some mud flat. There you go, that's brown. Obviously, you may not want to individually click every hex, so let's say you want to just make cover a lot of C terrain in one fell swoop. You can hold down the control key and the tool will draw a polygon, and as soon as you release the control key, that all of the points within, all the hexagons within the polygon will have whatever specified values applied to it. So that makes it easy to do larger swaths of terrain. So if we wanted to do some rough here, voila. And if you just click on a hex without pressing the shift key, it will populate the editor with whatever pre-existing values have been applied to that hex. So if we just click on a clear hex, you see it'll be reset to normal. If we click here, it'll be set to C. If we go back to Haiphong and click on that, all those values will be populated. So it's pretty straightforward to use. And hex side is basically the same. In the game, there's really only, I'm probably going to take out this China buffer zone trait. It's probably not needed. The only other kind of ridgeline would be, the only other kind of hex side in this game would probably be ridgeline. You can apply it anywhere, but let's apply it to thud ridge. So it's the same thing. Hold down the shift key, click on the hex side in question, and voila. What did I do? If you want to set it back to normal, you can just click back on it again. The control key polygon drawing feature doesn't work for hex sides because it's not terribly practical or useful to do it. It's only basically useful when you've got large swaths of hexes. One other thing I should probably point out is that in a few respects, the tool will enforce some constraints, like it won't allow you to apply inconsistent values. So for example, you can see right now entry area and orbit point are both grayed out because I have urban terrain selected. And the reason for that is entry point are these entry arrows, and it just so happens that none of the, like this is another entry arrow, right, entry arrows. None of those occur in urban terrain. In fact, they either occur in rough terrain or in sea terrain. If any other kind of terrain is selected, you see the entry area option grays out and is reset to none. So it's just a way of avoiding invalid terrain combinations. And likewise with orbit points, all of the orbit points happen to either be in normal terrain or in rough terrain. So anytime any other type of terrain is selected, the orbit point option is disabled. Right, so that's now an orbit point. You can see down in the lower left on the status bar, you can see it's now designated a VPAF orbit point. Now, for what it's worth, I haven't really enforced all of the terrain, all of the game constraints in here, and some of them, frankly, are just not even worth the effort. For example, making sure that you don't inadvertently designate an orbit point in a mudflat hex. I mean, there's so few orbit points. It probably takes more time to code the constraint than it does to just double check your work. But for other games, you know, it could be very useful to enforce those kind of constraints so you don't make errors when you're entering the terrain data. One other useful feature is these opacity sliders. Right now, both the terrain imagery and the map imagery are set to 100% opacity. But let's just say you want to be able to get a better view of the map imagery under, and you want to just suppress the terrain imagery. You can see if you slide this, like if you look on the upper left, you see the rough terrain is disappearing, the sea terrain is disappearing. Or alternatively, if you know the map image is kind of cluttered and you want to just get it more contrast to see what hexes you've applied what terrain to, you can vary those sliders, and you can vary them independently. So that could come in handy. And anyway, when you're done, you can save your work. If you're resuming, you can load the terrain. Right now, there's not an existing terrain file, so if I try that, oh, I must have accidentally saved it. Okay, well, I just overwrote my work. Not a big deal. It doesn't matter. This is just for demonstration. But anyway, you have loading and saving functionality. I should also point out that various other items portrayed on the map, like flak concentrations, airfields, bridges, ferries, all of these other various and sundry items, they're not represented in the terrain model. Instead, they are represented as independent class objects. I'll show you the, this is a partial diagram, UML diagram of the object structure, very partial. But so the base class of anything that exists and that can be attrited in the simulated battle space derives from the entity class. So obviously you have air entities because this is an air warfare game. You also have ground entities like AAA concentrations, NVA units, SAM battalions, fire can radars, that kind of thing. And likewise, targets that the US player would be striking are also derived indirectly from the entity class, but you know, airfield is its own subclass, runway, control tower, revetments. I won't go through the whole thing, but that's the basic idea. That's why I'm not. That's why none of these objects are included in the terrain model, because they're actually discrete objects in the simulation engine. All of those things will be added to the battle space at the source code level rather than in a user-created data file like the terrain would be. So it's important to point out that this tool, this editor application, this tool, it's not intended to be a freestanding utility for non-coders, you know, like something like Game Maker or similar programs. I'm not smart enough to make a data-driven application where all of the potentially complex interrelationships between terrain elements can be specified through like a drag and drop interface or in a text file or something like that. Instead, to use this kind of application to create a specific game, it's going to require modifications to the source code in order to adapt the utility to a particular game. For example, I'll show you the, let me show you the Hexagon Classic. You know, for example, you can see here the various terrain types: normal, urban, rough, marsh, sea. These are all specified at the source code level, so obviously that's not something that an end user can change. If you wanted to adapt this to your own game, you would have to open up the code in a source code editor and, you know, create your own enumerations with their own enumerants that are applicable to your particular game. And then you'd have to recompile, rebuild the application. But more importantly than these kinds of parameters, in order to use this utility to create a game, you'd have to understand and implement the various interrelationships and constraints of the game's terrain model. I mean, you know, the land terrain in downtown is of relatively little importance because it's primarily an air game. But let's say that under the rules of some other game, you can't have a road passing through a marsh hex. I mean, in that case, anytime the user would select marsh, you would want to disable the highway. Well, highway. You'd have to disable the highway option to avoid inadvertently applying invalid terrain characteristics to a hexagon, and that's the kind of thing. Maybe a better example is that in downtown, you don't even have to reflect roads as true pathways because you don't really move along roads. I think the only purpose of roads in the game is that their presence can be used for visual navigation by the U.S., and I think they allow placement of SAM battalions in otherwise inhospitable terrain. But other than that, they don't really have a game effect. But in other games, obviously, you might move along roads, and in that case, you wouldn't even want to have a road as a trait of a hex. You would probably want road to be a trait of a hex side, because functionally, in that game, the road represents a way to move between two hexes. So that's just one example of how all of this stuff here would have to be adapted to a particular game, and therefore this is not really something that this functionality is really not something that a non-coder could ever use. And in addition to that, there are a number of other game-specific values hardwired into the source code. So, I mean, for example, the map image file name and file path are all specified in source code. The individual piece image file names and file paths are specified in source code. The size of the hexagon in pixels is specified in source code. So those are just other impediments to a true non-coder utility. So just to wind up, I may extend the functionality of the editor to the creation of areas and area connections, or for area movement type games, or point-to-point movement games. And for that matter, some hex encounter games, may have area features, and so there may be some utility there as well. Another feature I'd like to add, not so much to the editor itself, but to the underlying hex grid representation, is to model hexagon vertices as independent objects that can be clicked and dragged around. And that would actually allow you to conform the shape of a hexagon to the natural terrain contours, which may be useful in certain games for clarity of presentation. Of course, once you start dragging the vertices around, it's not really a true hexagon anymore. It's just a six-sided polygon. But that could come in handy. That could facilitate a number of things. So that's another area of improvement. And that's it for now. Thank you for listening.